Good day everyone and a warm welcome to our presentation. Have you ever wondered how simple was polygon shapes can be transformed into extraordinary and innovative buildings around the world? In this project, we will explore the fascinating connection between mathematics, architecture, and sustainable development. We will discover how polygon shapes are creatively used in architectural design and how geometric concepts contribute to the Sustainable Development Goal 11. Throughout this project, we will explore how mathematics, particularly polygons, can be applied in real-life architecture. We will identify various polygon shapes found in buildings, examine creative and unique architectural design, discover how geometry plays an important role in creating buildings and communities that are beautiful, safe, functional, and sustainable. So, let's embark into an exciting journey into the world of polygons, architecture, and sustainable cities. We hope you enjoy our presentation and discover how mathematics can shape the world we live in. Let's begin!
Have you ever wondered why buildings around the world have such unique and fascinating shapes? The answer lies in the combination of art, science, and mathematics. Architecture reflects human creativity, culture, technological innovation, functionality, and environmental needs. The unique shapes and design of buildings are not created by chance. They are carefully planned to make structure not only visually appealing, but also functional, safe, and sustainable.
One visiting example in the story of mathematics is Carl Friedrich Gauss. In 1777 until 1855, he renowned German mathematician who made the significant contribution to many areas of mathematics. One of the remarkable achievements was demonstrating how a regular symmetric polygon, known as a heptadecagon, could be constructed using only a compass and side edge. This remarkable connection between a geometry and architecture shows us that mathematics is not a subject within the classroom, instead a powerful tool to shape a world around us, from the design of simple structure to some of the most iconic and informative building in the world. As we continue our presentation, let's discover how polygon and geometry can inspire creative architectural design of contribute to development of sustainable cities and communities.
Have you ever looked at remarkable building and wondered what makes its shape so unique and fascinating? The answer may be closer than you think. Geometry is all around us. Many of the world's most famous buildings are inspired by geometric shapes and patterns. Polygons, for example, can have different number of sides, and each polygon has a specific name based on number of sides it has. A triangle has 3 sides, a quadrilateral has 4 sides, a pentagon has 5 sides, a hexagon has 6 sides, an octagon has 8 sides. These different shapes and patterns are found not only in mathematics, but also architecture and the design of unique buildings around the world. Third, the creative use of geometry. Architects can transform simple shapes into extraordinary structures that reflect culture, innovations, and human creativity.
Here, in Malaysia, we can find many fascinating examples of geometric and architecture. Kota Kinabalu City, Moscow, features beautiful Islamic geometric patterns that reflect the rich culture and architectural heritage of the region. The Mustafa Tower in Kota Kinabalu is another remarkable example with its distinctive cylindrical form and innovative architectural design. Meanwhile, the Petronas Twin Tower incorporates Islamic geometric principles into their iconic design, while Merdeka 118 showcases modern geometric form combined with innovative architectural concepts. Even our school, SMK Kantlipo, incorporates simple geometric shapes such as rectangle, square, and triangle in various parts of its buildings, classroom, windows, and rooftop structures. Now, let us take a closer look at our 3D city model. In our model, we have a user verify of three-dimensional geometric shapes to design and construct different types of buildings. For example, this office building is mainly constructed using rectangular prism. Example show us that geometry is not just a topic we learn at the classroom. It's also essentially a part of a real world, especially in architecture, engineering, and urban design. Okay. Now, let's move on to an exciting part of our presentation. We would like to learn more about how polygon and geometry are connected to architecture and sustainable cities.
Today, we are pleased to have Sam is with us. We would like to ask him a few questions related to our project. Good day, Safis. How are you today?
I'm doing great. How about you?
I'm doing great.
Okay, you may have a seat.
Thank you, sir.
Okay.
We are currently working on a project about the Polygon architecture and sustainable cities. May we ask you about our project?
Of course, I would like to answer your question happily.
Thank you, sir. Let's begin. Sir, why are polygon and geometric shapes important in architecture and building design?
Okay, in my opinion, polygons and geometric shapes are important because they help architects to design buildings that are strong, stable, functional, and visually appealing. Geometry also allows architects to plan the structure, size, and arrangement of different parts of a building accurately. Do you get it?
Yes, Safis, I get it.
How can mathematics and geometry contribute to the development of sustainable cities and communities?
From my perspective, mathematics and geometry can help architects and engineers design buildings and urban spaces more efficiently. They can be used to plan the use of space, improve structural stability, and support designs that make better use of natural resources. In this way, geometry can contribute to creating safer, more functional, and sustainable communities.
Thank you very much, Shafis, for sharing your knowledge and valuable insight with us.
You're welcome, Hisham and Sharas.
As we come to the end of our presentation, we have discovered that polygons are much more than just shapes in mathematics. Through our project, we have learned how simple geometric shapes can be transformed into creative and meaningful architectural design. By building our 3D model, we were able to see how mathematics can come to life and how geometry is applied in real world and urban space. More importantly, this project has helped us to understand that the connection between mathematics, architectural, and sustainable goal 11. We have learned the design a city is not only about making buildings look beautiful. It's also about creating communities that are safe, inclusive, resistant, organized, and sustainable for everyone. Our 3D city model may be a smaller model, but it represents a big idea that the cities of the future begin with creative ideas, thoughtful design, and innovative solutions. So, from a simple triangle, square, and polygon, we can imagine a building. From buildings, we can design communities, and from communities, we can build better and more sustainable cities for the future generation. We believe that when mathematics meets creativity, imagination can become reality. Let us continue to think creatively, design responsibly, and build sustainably. The future of our cities is not only about the building we got today, but also the better world we create for tomorrow. Thank you for joining us on our journey from polygon to architecture, from 3D city model to sustainable cities. Together, let us shape the cities for the future. Thank you and have a wonderful day. Bye. Bye.